a concave mirror. Now you can see radius of curvature is how many centimeters? 180 centimeters written. Radius is how many centimeters? 180 centimeters. Then diameter is basically the aperture of that, so that you don't have to worry. But radius of curvature is how much? 180 centimeters. So focal length is how much? 90. And let's change it as per our question. So in our question it was how much? So focal length is how much?
75.
Now, if I place my object at center of curvature, this distance is actually 75. Sorry, 180. This yellow dot, you can see yellow dot in the middle. That is your focus.
Yes.
That is your focus. So
Yes.
there was a question, no, can we like draw light rays tangential? There is no problem with that. You can draw any way you want. But the parallel ones are like easy to draw. That is fine. So we are not going for rays right now. Just see. If the object is at focus, so see, here they meet. So which is this point first of all? Which is this point? This point is center of curvature because this is the point where they meet. Now when I took the object distance as 45, that means I went somewhere here, isn't it? From 60 I reached 45, no, so I have to go closer. Now what can you predict from here? First of all, you can see your pencil is bigger, right? Right. So your image is magnified, enlarged. Then what else you can predict? One thing also you can predict that it's downwards, right? If the object is facing upwards, this is facing downwards. And one more thing you got to know that this is beyond center of curvature. So if the object is moving this way, the image is moving that way. Again, if you move it, this is the point where they meet. Now let's increase the object distance beyond center of curvature. So let's make that as 90 or something. Then you find the image is moving towards focus. Are you getting it between focus? And now the situation is reversed. Now the object is bigger and the image is getting smaller. So whenever you get confused, actually ray diagram gives you a lot of information. The only thing is, for finding a numerical value, you'll have to do it using scale, to the scale. Apart from that, it tells you everything about that. Now if you move it further closer, no, let's say you crossed focus. Suddenly something will happen at focus. Now you are getting the image on the other side. So if you take a value in the same question, let's say center of curvature is at 60, focus is at 30. If I take a distance, let's say 15, then till now you are getting V as a negative answer. If I take U as 15, you will start getting a positive answer. Now, virtual image made by concave mirror, is it smaller than the object or bigger than the object? If you have a convex mirror, then it doesn't matter where you place your object. Image is always of what kind? Right? Virtual and smaller than the object at all points. That is why you don't study convex mirror much. Because it has just one property. It will create a virtual image and that will always be smaller than the object. But in case of concave mirror, there are games. The object meets, then sometimes object becomes bigger, sometimes image becomes bigger. Are you getting it? Depending on their locations. And it can be real, it can be virtual as well. Are you getting it? Depending on what object distance you are. Is that clear? What is the way to master this topic? To master this topic, whenever you feel like you are forgetting sign convention or anything, take a focal length. You can take from here also 75. Then take object distance, different object distance. Take object distance is 100, then less than 75. Right, then more than 150, and just solve it. The answer itself will tell you where the image is, where the object is, how the changes are happening. The other way is draw the ray diagrams, and that will give you the picture. Or finally, see the simulation like this. Story of plane mirror is very simple. No discrimination at all. If there is a real object, the image is functional. Here.